Hello again, welcome back to Understanding VXLAN using BGP EVPN. This is going to be video 6. Now if you are going to be labbing this up at home, there's a few things for the Nexus 9K that you might want to know. Now the Nexus 9K, you can get it for free if you have a username and password for cisco.com. That's where I got mine. When you are loading the 9K, it's going to ask you, let me bring this up so you can see it. It's going to ask for this right here, in which case you're going to say yes. So it says abort power on, right? So we're not going to have PoE. This is a virtual IOS. So you're going to say yes here, and it might ask it a couple more times, as you can see here. Just wait until you get to this point, and when you get to this point, you're going to say no, and it's going to ask you for a password. Now I put the super secret password of Cisco here, and then it'll ask you to log in, which is what I did. Admin will be the username, Cisco would be the password. There's a few other things that you want to do on the Nexus. So since it's going to be a brand new install, let's say if you don't do this, it's going to come up and go to ROM every time. So let's look at the image here. And you're gonna want to save this image so that every time the Nexus boots up, it always loads to this image. If not, you're gonna have to tell it from ROM how to load to it, right? So because I erased the config on this and I reloaded it, for whatever reason it did keep it. So if I do a show boot, you will see it's there, right? But otherwise you'd have to go into config T and you have to type this in there and do write mem. Now that's the other thing, write mem doesn't work on here, right? So I do have an alias here. I have it saved. So for the Nexus, this would be the command, so that you can just type in RW, and the alias is going to be RW for copy running config startup config. So now all I have to do is just say RW and it saves the config. We're going to run into some other issues, and that's why I have these in here, and you will see them as we're typing the configuration in. It's going to pop up as a message. We're going to have to run this command or both of these and then reload every time. So I'll spare you that, and I'll pause it as it reloads. So let's go over the 9K a little bit. So one of the biggest selling points of the Nexus 9K is that it's a monolithic switch. It runs Cisco NX OS, which is built on a modular Linux-based architecture. Let me explain the Lego architecture. In older network operating systems, if a single protocol like BGP hit a bug and crashed, it could take the entire operating system down with it, forcing a full reboot. On a Nexus 9K, every protocol runs as its own independent process in its own protected memory space. So if your BGP process crashes, the rest of the switch, which is your management, your physical ports, and other protocols running spanning tree or LACP, they keep running. The switch can often restart just that one failed process in the background. It's kind of like a modern web browser. If one tab crashes, it doesn't close your whole browser. It just refreshes that one tab. So this is how it works. When you first log into a Nexus 9K, it's intentionally empty. If you try to type a BGP command or even BGP, router BGP, the switch won't even recognize it. You have to explicitly use the feature command. So let me do that here. I'll try to run BGP, router, BGP, and it doesn't work. But if I type in feature, BGP, now it's enabling BGP. Now I can go in here to type router, BGP, 6500, and it works. We'll do the same thing for OSPF, router, OSPF1, will not work. Feature, OSPF, and now router OSPF1. So think of the 9K like a high-end PC. On a regular switch, if a program crashes, you get the blue screen of death. On a Nexus, the switch just opens the task manager, restarts the app, and keeps going like nothing happened. Okay, so let's enable some of the features we'll be needing. We already enabled BGP and OSPF. I like to enable LLDP. And let's do this just so I can show you also have to enable interface VLAN, right? So if you try to do interface VLAN 10, it won't let you. The feature is feature interface VLAN. And now I can do interface VLAN 10. So that might be something that you can forget. But it's vitally important. Okay, so let's talk about the NV overlay feature command. On a Cisco Nexus switch, like your VTEP, like the VTEP we're on, the data plane, which is the muscles, are kept lean and mean. By default, the switch doesn't know how to do fancy things like VXLAN because those apps aren't loaded into memory. So this command is the on switch for network virtualization. In Nexus OS, you can't just start typing VXLAN commands. The switch will literally tell you the command doesn't exist. Feature NV overlay tells the switch's operating system, I need you to load the specific software modules and prepare the hardware ASIC to handle encapsulation and decapsulation. Without this command, your switch is just a standard layer 2, layer 3 box. It doesn't have the instructions or the muscles to build an overlay. Alright, the next command is going to be the NV overlay EVPN. Okay, so what does this do? Alright, well, welcome to VTEP 1. Now that the spines are ready to act as the air traffic controllers, we need to turn on the actual VXLAN EVPN engines on the leaf switches. NV overlay, so this stands for Network Virtualization Overlay. It tells the switch, prepare your hardware to wrap layer 2 frames inside layer 3 packets. The EVM part. This specifically tells the switch that we will be using BGP EVPN as a method for sharing MAC and IP address information. Why do we need it? Well, without this command, the switch is just a standard dumb switch or router. If you don't type this first, the switch won't even let you type other VXLAN commands like VNI or interface NVE1. It would be like trying to run an app on a phone that hasn't had the operating system updated to support it. It also tells the internal ASIC to carve out special memory space to store VXLAN instructions and to prepare the muscle, which is the data plane, for encapsulation. Thank you for watching video 6 in the series. We'll continue configuring VTEP 1 on the next video. I'll see you there. Welcome back to Understanding VXLAN using BGP EVPN. This is going to be video number 3. So I want to go over again on the spine the command under the interfaces IP OSPF network point to point. So hopefully you have an understanding through the CCNA or CCNP about the different connection types with OSPF, one of them being point to point, another one is multi-point, and another one's broadcast, right? So to understand this, you got to remember that Ethernet, it's like connecting to multiple switches or one switch and multiple routers to it. It would be seen as a broadcast, right? So you'd have to use, or by default, OSPF would use broadcast. In this example, though, because we're making a point-to-point connection, that's what we want to use. So it doesn't have to go through all of the election process to pick a leader. It's just going to know it's point-to-point. And as I said before, it's going to save you like 40 seconds. Alright, so in this video, what I'm going to do is I'm going to go ahead and just type all the BGP commands, and you can fast forward through it, but I'm going to type them all in and then go through all these commands. Alright, so now let's go through an explanation of all these commands. Alright, so under the routing process of BGP 6500, we have BGP router ID 1.1.1.1. Now if we were to look at OSPF, we would also see it has an ID of 1.1.1.1. Now it doesn't really matter for both of them to use this, because BGP is a completely set of instructions here. OSPF uses that ID to build the physical map, which is the underlay, and BGP uses the ID to build the directory of the overlay. So basically the way I understand that is when I hear directory, it's going to have a table of MAC addresses. It's going to be all the MAC addresses of these guys here, and BGP is going to have it on every single VTEP. So if you didn't have a BGP router ID, the router would try to guess one, usually by picking its highest IP address. In a complex VXLAN fabric, guessing is dangerous. If two routers guess the same ID, they'll refuse to talk to each other and your BGP will never come up. Also, BGP is very picky. If it hears about the same network from two different places and all other things are equal, it uses the router ID as a final tiebreaker. The lower ID wins. For loop prevention, the spine adds its ID to the routes as it passes along. When it sees a route coming back with its own ID on it, it knows, hey, I've seen this before, and drops it to prevent a loop. Alright, now let's talk about the neighbor VTEPs peer group. So in a network like this, with multiple VTEPs, with VTEPs 1, 2, and 3, connecting to the same spines, the peer group is your best friend for keeping things organized. Imagine you have like 50 VTEP switches instead of just 3. For every single one of those 50 neighbors, you would have to type out the remote AS number, the update source, in this case loopback 0, the address family, EVPN settings, and the route reflector instructions. That's a lot of typing, and it's very easy to make a mistake on just one line, which would break the whole fabric. The peer group acts like a template or a folder. You define the instructions once inside the group, and then you just tell the router which neighbors belong in that group. The command works in two stages. Stage 1 is creating the template. So the template would be neighbor VTEPS peer group, neighbor VTEPS remote AS6500, and neighbor VTEPS update source loopback. When you type the neighbor VTEPS peer group, this creates a folder named VTEPS. And then the other lines add the specific instructions to that folder. Now any router put into this folder will automatically inherit these settings. Stage 2, well, now we're adding the neighbors. So we have neighbor, this loopback, and these right here. So each of these VTEPs here. So this is 1.1.1.1, 2.2.2.2, or 22. You know what I mean? And so on and so forth for these 4 routers here. So this tells the spine, sees these 3 IP addresses, they're all VTEPs. Give them all the settings I have saved in the VTEP folder. Some benefits are consistency. It ensures that every VTEP is treated exactly the same way by the spine. Efficiency. It reduces the work the router CPU has. Let me say that again. It reduces the work the router CPU has to do. Instead of calculating the same update 50 different times for 50 neighbors, the spine calculates it once for the group and sends it out to everyone. And speed. If you need to change a setting, like a password or a timer, you only need it in the group, and it instantly updates for all neighbors. The next command is the address family L2 VPN EVPN. This is where we move from standard BGP into VXLAN BGP. Think of BGP like a multilingual translator. By default, BGP speaks IPv4 unicast, the language of the internet. And you'll see that, you don't see that here, but if you were configuring BGP, you would probably, depending on the router, the iOS, you would probably have to add address family and the IPv4 unicast, and then you could have a routing table, the IP routing table. In this case, it's going to be the EVPN routing table. BGP is very flexible and can learn other languages or address families, in this case, the L2 VPN EVPN. L2 VPN stands for Layer 2 Virtual Private Network. It tells BGP we want to share information about Ethernet networks, the MAC addresses, not just IP addresses. EVPN stands for Ethernet VPN. This is the modern dialect of L2 VPN, specifically designed for VXLAN. I want to explain what the rest of the commands mean and what they do, but I'm going to have to do it in the next video. So I will see you in the next video to explain the send community both, the VTEP route reflector client, and then the activating the neighbors. I'll see you in the next video.